Now let's look at graphing transformations. Let's take y equals the absolute value of x plus 5 and add 2. Let's talk about these transformations. Inside our graph, we have x plus 5. Well, remember, x is a liar, and we really want to move left 5 units. But we also want to move up 2 units to graph. We know the x values are actually moving left, so we're going to subtract 5 from x, and for the y, we're going to add 2. Now remember, I'm getting these points from our original key points, so if I subtract 5, we'll have negative 2 minus 5. This will give negative 7. Negative 1 minus 5 is negative 6. 0 minus 5 is negative 5. 1 minus 5 is negative 4. And 2 minus 5 is negative 3. For the y values, we're adding 2. So we have 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So these are all the y values. So the new graph is right here. And if I looked at the original parent function point, and we know it started right here, we could see that it moved left 1, 2, 3, 4, 5. So it moved left 5 units. And it moved up to this point 2 units. So the original was right here and it moved. So this is what I was talking about being my starting point. Let's look at the domain and range of our new function. Remember, the domain is our x values. So I'm starting at the new function on the right hand side, and if I arrow down to the x-axis on the right side until I get to the end of the graph, and realize this graph, because of the arrow, it keeps going to the right to where? Infinity. Then to the right of my starting point, all the way to the end of the graph, this is going to positive infinity. Now let's look at the left-hand side, and let's arrow down to the x-axis. And I would keep going also to the x-axis to the left of the starting point to negative infinity. So it still has the same qualities that the parent function has. The domain of any of the children will also be negative infinity to infinity, which is all real numbers. Let's look at the range. The range are our y values. So let's take the range from a graph, from the lowest point on a graph to the highest point, and let's draw those points to the y-axis. And in this case, we're going to keep going up because there's an arrow here. Graph starts here all the way to positive infinity. Well, what's the y value at this point? It's a positive 2. So the graph is starting at 2 and going to positive infinity. Remember, 2 is in brackets because this is a solid dot right here. Let's look at graph 2. In graph 2, we have negative 2 times the absolute value of x plus 1. Let's write down the original numbers. What are the transformations? The vertical transformations, or the y transformations, will be reflecting across the x-axis because of the negative sign. This is a stretch by 2, and we're moving up 1. So these are all the vertical transformations. There are no horizontal transformations. So that means the x value stays the same. So let's get our new chart. The y is negative 2y plus 1, but the x values stay the same. So the new translated graph looks like this. And you can see that this graph actually did move up 1. And now you can also see that it did stretch by 2 units. What is the domain and range? Well, let's look at the domain. If we arrow to the x-axis everywhere we have our graph, we stop at our stopping point, which in this case is an arrow, and in this case I have an arrow down here as well. From our starting point on our graph, we are going to the right to positive infinity, and to the left to negative infinity. So the domain is negative infinity to positive infinity, which is all real numbers. This is the same as the parent function. Let's look at the range, and let's arrow from our starting point to the y-axis. Notice that this keeps going because of the arrow on this side. Now let's look at the right side. An arrow towards the y-axis. Again, because of this arrow, it keeps going to negative infinity. So from the starting point, following the arrow down, we can see this is actually going from negative infinity to 1. Remember, we want to write it smallest to greatest.